I know all what you've all been waiting for, another red puzzle. Here we go. So weather systems are going to be the things that we talk about when they come in. So when we're talking about there's rain coming, there's a storm coming, that's a weather system. When you see something coming across the land, it basically goes across with the winds of the earth, the rotation of the earth, and then things of that. So your global wind systems are important for these systems. You will have the winds pushing these systems through. So it's a combination of your air mass, it's a combination of your wind systems, a combination of the rotation of the earth. Um, so the Coriolis effect results in fluids and objects moving in apparent curved path rather than a straight line. So as the earth rotates, it makes everything move in a curved path. That's the reason why you don't see winds blow straight one direction. They will always change. If the Earth is a sphere, that's how we get the Coriolis effect. So you'll see another thing. So if you look at the flush of a toilet, you see how it spins around in there. That is not due to the water. That is due to the Coriolis effect. In fact, on the other side of the Earth, so in Australia, the water will actually spin the opposite direction because of where they are in relation to the Earth's spin. This is how another way we can figure out how the Earth's not flat anymore. Not anymore. Not flat. Uh, and like it says, it moves in a curved path instead of a straight line because the Earth's surface is curved. All right. So the direction of the Earth's winds, such as polar easterlies and trade winds, vary with the latitude. So you can see the polar easterlies go to a certain point and then they switch. Then our westerlies will start to go this way. We also have what we call jet streams in the United States, which are a little bit different than anywhere else in the world. They are a part of the westerlies, but they flow in a little bit different way. Your trade winds will move towards the west from the east, and then you have your westerlies that are in the south, and then your polar easterlies as well. So your polar easterlies are between 60 degrees north and the North Pole and 60 degrees south and the South Pole. They will flow from the east to the west. That is how it goes. Now, your prevailing westerlies are 30 to 60 in both north and south. This is what we feel more often than not. It goes from west to east. So it will push. That's why we don't see our weather systems, except for hurricanes, go from east to west. Everything goes west to east because of these winds. And trade winds, the reason why they're called trade winds is because a lot of the time this is how boats would get to the west from the east. So you have a lot of trade. You've heard of the slave trade and the cotton trade and all that. That is coming based on the effect of how it works, or the effect of the winds. So basically, the winds were what you would catch to go from either North America to Europe or from Europe to North America. And this is where the trade winds name comes from. It blows from the east to the west. Trade winds is the majority of the middle of our Earth. So near 30 degrees north and 30 degrees south, we have sinking air associated with trade winds causing an area of high pressure. This results in a belt of weak surface winds called the horse latitudes. So meaning that you do not feel much wind at this area. So at these lines, there is much less wind. Trade winds from the north and south equator join at the equator, and that's where you have your intertropical zone. So we have a lot more weather systems push into this area. This is where you'll see a lot of your hurricanes start to create. Jet streams. Jet streams are special things that we have mostly in the United States compared to anywhere else in the world. Now, it does go across the entire Earth, but you hear about jet streams a lot more in effect with the weather in the US and Canada than anywhere else because of the weather that comes with those jet streams. Now, large temperature in the upper area combined with the Coriolis effect and strong westerly winds creates these jet streams. So a jet stream is a narrow band of fast, high altitude winds. So this is what is way up in the altitude that pushes weather systems in our area. They are fast moving. Have you ever heard of, I know if you played baseball or you've watched baseball, you've heard of, well, that ball hit a jet stream because of how high up it went. That's not necessarily true, but there are lower to the ground, higher air velocities sometimes that can affect baseball, but that's beside the point. Jet streams are very high and they are very fast moving winds. So there are subtropical and there are polar. So polar jet streams are separate from the polar easterlies. They actually are more towards the prevailing westerlies. So they are basically where the easterlies and westerlies meet. A miter jet stream is the subtropical jet streams. These are where the trade winds meet the westerlies. So storms along the jet streams can generate large-scale weather systems. So we're talking about blizzards, we're talking about tornadoes, large temperature changes. So jet streams have the ability to change the temperature from one direction, from one region to another. So it can basically, you're seeing in this picture that it's cutting off the cold and the heat. That's where the jet streams are. You can actually follow the jet streams and you can figure out where. So this is how meteorologists work a lot in the United States. If you follow what the jet streams are doing, you'll be able to follow what the next weather system is going to do. I am going to post that with this, or a link to our jet streams with this video for you to check it out. So fronts are a collision of two air masses. So normally this is a high and low air pressure, or a cold and warm air front that usually creates these different types of storms. So a cold front is represented by your blue triangles. When a cold, dense air displaces a warm air, it forces the warm air, which is less dense, up along the slope, and the collision creates a cold front. So this means that we're pushing the air up higher into the atmosphere, and the colder air is what drops, because we know that molecules that are colder are going to be close to the ground, and molecules that are warmer are going to be higher up to the atmosphere. Warm front, which is represented by these red half circles, displaces a cold front along a warm front. Warm front develops gradual boundary shape. So that means it will push the cold air further away. You'll see different types of weather with each one of these, but a stationary front is where you see the two masses meet and kind of stall. So stationary front frequently occurs between two modified air masses that have small temperature and gradient different temperatures. This will happen more in a tropical area where you're not going to see a drop into, say you had air that was in the 70s the day before, you're not going to see a drop in Florida from 70s to 32 very often. You'll see it more stay stagnant in the middle and stay more like around the 50s, and that's what a stationary front creates. An occluded front is represented by a purple line. So sometimes cold masses move so rapidly it overtakes the warm front and causes the warm air to move upward. As the warm air is lifted, the advancing cold air mass collides with the cold air mass in front of the warm, and this is called occluded. So this can create a big dump of rain in this fact, because we are pushing the warm air up so fast that something has to come down. Pressure systems So when I was talking about high and low pressure systems, this is the sinking or rising of air combined with the Coriolis effect. So as the cold air sinks or as the warm air rises, so low pressure system cyclone is going to be a warming rise air, and a high pressure anticyclone is going to be colder air, more often than not dropping. Low pressure systems, air rises. That means you'll see more air spiraling in the air upwards towards the center. High pressure systems are sinking, so they're moving away from the system, reaching the Earth's surface. These high and low air pressure systems bring different types of weather with them as well. In the northern hemisphere, winds move counterclockwise according to the low pressure system center, and clockwise around a high pressure center. So as we move into a high pressure, they're going to move clockwise, and they're moving down into a low pressure system as we go up. All right. We'll talk about the combination of pressure, uh, temperature, and winds creates your weather fronts. So it just depends on what you'll see more often than not. So you can decide based on, and we'll talk more about it in the next Edpuzzle, what actually happens with these different types of fronts. All right, that is all for today. I'm sorry it took 10 to 11 minutes. Have a great day.